Hi everyone, it's Mr. H here, and today we're going to talk about the laws of exponents. In fact, I'm going to do two videos on this. In one, I'm going to cover the basic exponent laws, and in the second video, I'm going to cover what happens if you have a fraction in the exponent. And so for the course I'm teaching, this is section 4.2 and 4.3, but between these two sections in these two videos, we're going to cover all the exponent laws that there are. So let's look at what an exponent is first off. Well, it comes from a power. Something that is a power has both a base and an exponent. And you can see it written there, 5 to the power of 3. The exponent is 3, the base is 5. So let's do a little bit of review of exponents that we would have seen in the past as we get into these exponent laws. So evaluate the following. Write with a single base before evaluation if necessary. So this first one, negative 3 to the power of 3, well, just to review this, if we write this in expanded form, we're not going to write them all like this, but it's writing like negative 3 times negative 3 times negative 3, and if you wanted to, you can put those in brackets, but the point is that it's negative all 3 times. And so if you have an odd number of negatives, then negative times negative makes it positive, and then times another negative makes it negative again. And 3 times 3 times 3 makes it 27. So the first one's negative 27. Now this next one is negative 3 to the power of 4. So we're taking negative 3 and we're multiplying it by itself 4 times, just like we did when we had the power of 3. So in this case, negative 3, again, I could write it out as expanded form. I don't have to, but this is known as expanded form. So 3 and 4 negative 3s. And so negative times negative is positive. Another negative times a negative is positive. So this is positive 81. So what's the takeaway here? Well, remember that if we have a negative in brackets, that if we have an even exponent, then what we are going to get is a positive answer. But if we have an odd exponent, like 3, what we get in that case is a negative answer. All right, so moving on, negative 3 to the power of 4. In this case, it's negative, and then it's 3 times 3 times 3 times 3, because we don't have the bracket. So in this case, it's negative 81. In the next case, we'll name this rule in a minute, but you might remember that if you have the same base, you can add the exponents. And so in this case, we say it's 3 to the power of 7, and 3 to the power of 7, 2,187. Notice it said to write as a single base before evaluation, so that's what we did there. This one we're going to do the same thing. So 3 to the power of 4 divided by 3 squared. We're going to subtract the exponents. Again, if you needed to see that written out in expanded form, you could have written it as 3 times 3 times 3. So there's 3 to the power of 4. And then we're dividing that by 3 times 3, 3 to the power of 2. And so that factor of 3 cancels with that one cancels with that, and we're left with 3 to the power of 2. So we subtract those exponents. So that gives us an answer of 9. The last one is, again, we'll name it below, but it's the power of a power rule. We multiply this power by that one. So if you have a power inside the brackets, multiply it by the one outside the brackets. So we get negative 3 to the power of 6. We multiply them together. And then negative 3 to the power of 6, because it's an even exponent, it's positive. And then it's 729. All right, so there's some quick review of what we've done in the past. Let's look at the exponent rules for our lesson today. So the laws of exponents, in these laws we're going to use m and n as positive integers, meaning they're 1, 2, 3, 4, 5, 6, 7, etc. A is any real value, so it can be anything. It can be a decimal, it can be a fraction, it doesn't matter. It's important to note that in the first two laws, the powers being multiplied and divided must have the same base. We saw this a minute ago with 3 to the power of 4 and 3 to the power of 3. So we use that as our example for this first one. 3 to the power of 4 times 3 to the power of 3 meant that we add those exponents. So it's we add 4 plus 3, and we get 3 to the power of 7, which we then answer, and we got 2,187. But the key there is getting it to the 3 to the power of 7. For law number 2, this is the quotient rule. So we've got the product rule if they're multiplied, and now the quotient rule if they're divided, because it's a quotient. So we're taking that exponent m and we're subtracting n from it. So a minute ago, we had the example of 3 to the power of 4. We divided that by 3 squared. And so we're going 4 minus 2. And so that gave us 3 to the power of 2, which was 9. So there's an example of that one. Now we move on to the power of a power rule, and we saw the first one in our examples above. A to the power of m to the power of n. So the example that we had there was -3, I believe it was squared first, I can't remember, but then it was cubed. And what we do is we multiply these two together. So we get -3 to the power of 6, and then we were able to expand that out and get 729. But the key is that we're multiplying those two together to get a power of 6 in this case. We can expand this rule into a couple of situations. One, if we have two different bases that have different exponents, all to the same power. And then the second case is if we have a fraction. So let's look at the case where we have these two things multiplied together, all to the same power. So let's consider the example of 2 to the power of 4 times 3 to the power of 5, all to the power of 2. And so what we're going to do is we're going to use, it's going to look like the distributive property. We're multiplying the exponents in the brackets by the exponent outside of the brackets. So 2 to the power of 4 times 2. I'm going to write this out like this. You don't have to write it like this, but just so you can see it this first time, I'm going to do this. And then 5 times 2. So we can get 2 to the power of 8 times 3 to the power of 10. Now, at that point, that would probably suffice if it didn't say evaluate. But if it does say evaluate, we should evaluate this. This gives us 256. Notice we can't add 8 plus 10 because they don't have the same base. This is 256, and then 3 to the power of 10, not 30, it's 59,049. And so if we multiply those two things together, we get an answer of a very big number, 15116,544. So 15,116,544 would be our final answer there. Let's apply this now to the quotient rule. So if we have it's a fraction sign, it means like division. And so if I gave you 2 to the power of 3 over 3 to the power of 4, and then I put that to the power of 2, what I'm going to do is very similar to what I did before, but I'm not just multiplying the numerator, I'm also multiplying it by the exponent in the denominator. So this gives me 2 to the power of 6, and then 3 to the power of 8. And so 2 to the power of 6 would give me an answer of 64. 3 to the power of 8 would give me an answer of 6,561, and I could try to simplify that. Don't think we can, but that would suffice as a final answer for that. So same idea, but applied to a fraction. The next example is for something that we have anything really to the power of 0. And this applies to, I could do it's -3 to the power of 0. Well, that's going to be 1. I could do 59,000 to the power of 0, and that's going to be 1 as well. Any single number to the power of 0 equals 1. And it says this, from law 1, since a to the n, so the very first law we looked at, the product rule, times a to the power of 0, so if we have the same base, so let's say we had 3 to the power of 3, and then we go times 3 to the power of 0, gives me 3 to the power of, not 0, 3 to the power of 3. And that's just adding those. 3 plus 0 gives me 3. And so that must mean that 3 to the power of 0 equals 1. Law number 7, this is the last law I'm going to look at in this video, is if we have a negative exponent. And all we do with a negative exponent is we bring it down to the denominator. And the way we do that is, for example, if I have 5 to the -2, I write that as 1 over 5, and I make it positive in the denominator, 5 squared. So that's 1 over 25. So that would be an example of that law number 7. Now some of you might need a little more convincing on law 6 and 7. So what I'm going to do is I'm just going to scroll down here and show you one other way to think about law number 6 and 7 that hopefully will be helpful. I'm going to do that with powers of 2. If you have 2 to the power of 3, that's equal to 8. 2 to the power of 2 is equal to 4. 2 to the power of 1 is equal to 2. Well, what's 2 to the power of 0? And what's 2 to the power of -1? What's 2 to the power of -2? Well, if you look at the pattern that's forming here, we're dividing by 2. We're dividing by 2. So naturally, we would follow that pattern. That's what mathematics is all about, finding patterns. And we go 2 divided by 2, we get 1. 2 to the power of 0 equals 1. And that follows with law number 6 that we looked at above. And if we keep going with this, 2 to the power of negative 1, well, we would expect this, if we divide by 2 again, to be 1/2. Well, remember that rule we just looked at for law number 7, it's 1 over 2 to the power of positive 1, and 1 over 2 to the power of positive 1 is 1 over 2. If we do that again, divide by 2 again, we would get 1 over 4. And again, 2 to the power of negative 2 is 1 over 2 squared, making it positive when you flip it, which gives you 1 over 4. And so that's simply another way to look at it. If you need convincing, try doing the same thing with powers of 3. I'm not going to take it up here in this video, but you could do this and see what happens. You're dividing by 3 each time when you do powers of negative 3. All right, back to the handout. What I'd like you to do now is pause the video and try to do these questions. We're not going to do the last 3 here today, so we'll leave those for the next lesson, the next video. But we're going to try to do all the other questions, and then just check your answers with me. I'll come back after you've paused the video, play it again, and I'll answer those for you. All right, so hopefully you have had a chance to do those yourself and try them out. Don't just follow what I'm doing. Think it out yourself. This first one, we get 4 cubed, 3, and 5. We add them together. That gives us 4 to the power of 10. It's just saying write as a single power. So it doesn't say to get a final answer. So I've just written that as a single power. The next one is 7 squared. And so we get 7 to the power of 6. And we're dividing by 7 to the power of 3, which gives me 7 to the power of 3. Let's just subtract them across the exponents. Now division can be written as the fraction sign or as the division sign like that. And sometimes it's easier to write it as the division sign. The next one says write as a single power. So again, I've got the same base, even though they're fractions, they're the same base, 5 over 3. So I can go ahead and I can write those as 5 over 3 to the power of 6. Now that's written as a single power, but I do want to note that when you expand that out, it would be 5 to the power of 6 over 3 to the power of 6. All right, so that's the final answer, but it would expand out like that. The next one, 5 to the power of 3 squared, so we multiply these together. So 5 to the power of 6 times 5 to the power of 12, which gives me 5 to the power of 18 by adding those together. So we've got the power of a power rule, and we have the product rule. Now it says to evaluate. So these ones we actually have to get an answer for. Now, some of you would be tempted just to put this in your calculator and get an answer. The problem with that is we're not always going to see numbers. We're going to see some cases over the next few days where we're going to deal with just letters. So if I put a to the power of negative 3, what would that mean? Or a over b to the power of negative 3, what would that mean? So it's good to not just get an answer initially, but simplify it as much as you can using the exponent rules and then get an answer. In fact, I'm just going to point this out. If you don't simplify it using the exponent rules, you're not going to get full marks. So you need to simplify using the exponent rules before you use a calculator. Very important we do that. So negative 5 to the power of negative 3. So this becomes negative 1 over, because it's just the negatives, there's no brackets, so it means the whole thing's going to be negative, 5 to the power of 3. 5 to the power of 3, 5 times 5 is 25, times 5 is 125. So that gives me negative 1 over 125. This next one would, the negative, we might be tempted to bring it in first. I would encourage us to flip it right away. Because what it's going to do is it's going to end up bringing the 3 down to the denominator. And if there's something in the denominator, it's actually going to bring it up to the numerator. So this becomes 4/3 to the power of 3. And so we get 4 cubed divided by 3 cubed. 4 cubed, 4 times 4 is 16, times 4 is 64. And then over 27 in the denominator. This next one has a subtraction, notice that. So it's not, we're not multiplying here or dividing, it's subtraction. Anything to the power of 0 is 1, and we're going to subtract from that 1 over 2 squared. That's saying 1 minus 1/4. And we know that 1 is 4 over 4, so hopefully you can say what's 1 minus 1/4, but if not, we can break it down to a common denominator and we get 3/4. And the last one for today is this one here. We've got fractions inside of fractions, so we're going to up over here, remember that we flipped the whole thing, but here we have a plus sign separating them, so we can't just flip the top and the bottom. We have to do each bit by bit. So I'm going to go 1 over 2 to the power of 1 plus, if I can get my pen working, plus 1 over 2 squared, because 2 to the negative 2, we flip it and it's positive 2, divided by 1 over 3 to the power of 1. And so this gives me 1/2 plus 1/4, and we're going to divide that by 1/3. You notice how I've written that with, change the fraction to a division sign just to make it a little easier because we know we're going to end up flipping and multiplying. So 1/2 plus 1/4 is 2 over 4 plus 1/4, so it's 3/4. And then if we divide by a fraction, we have to multiply by the reciprocal. And so the reciprocal ends up being 3 over 1, and we get 9 over 4 as our answer for that. So there you go. There's some look at the exponent rules. We're going to take another look at this in the next video, which if you're in my class is going to be happening tomorrow. There you go. If any questions, by all means, reach out. I'm happy to help.